Hi, welcome back. Um, my last video was about a centrifugal pump. I actually, I printed it and I tried it out and it worked. It worked great. Um, I kept on studying a little bit more about pumps and I found an interesting concept which was the screw type pump. So every one I found or designs were fabricated with square threads, and Fusion 360 permits you to make square threads, but I decided to go with Acme threads instead, only because Acme threads I can do a left and a right Acme thread, but if I make a square thread I have to use the spring function under modify, or no, under create, and in the tab it says I can either make it a triangle, a square, or a circle, and there might be one more, I'm not sure, I can't remember. But if you make it a square, you have to figure out the length of that spring to make sure you have the equal distance between the solid and the cutout of that spring. And the Acme threads did this for me, the thread command, but the spring, I was not able to flip it over to get a left and a right hand square thread out of it. So I went with the Acme thread. So as far as volumetric, I believe the Acme thread is not going to shift a larger volume of material within that thread compared to the square thread, but it should function just the same. And what you hear right now in the background is the printer printing one of these screws. Also, I had difficulty trying to find the distance between the two screws. Like, for them to mesh perfectly, you have to have like, I don't know, 5 to 10,000 root clearance, so you can mesh them so they don't bind together. And the closest you can get them to fitting together means, as far as positive displacement, it should be better, but the fact that when you crush a material, a liquid, you create heat. So maybe a larger gap is better. I'm not sure. I'm not sure about these principles, right? When it comes to probably speed is a factor. If it's spinning too fast, you're creating more pressure between the screws, right? And if you go slower, well, if it's got a higher viscosity, you're going to have a better flow. And if it's only a liquid with not viscosity, but density, I guess, or, well, the slower it pours, the more you get out of your positive displacement, right? And it's going to be 2 screws meshed together with gears. Now I'm going to try to figure out how to do a involute gear or constant mesh gear, so these 2 gears will fit together nicely. And only one's going to be a driver, right? And I'm going to do the same thing as I did before with the centrifugal pump. I am going to use a drill bit, and yeah, I'll use a drill bit to run the driver. That's pretty much it. So let's get on with it. This is my second print for my second screw. One is a left-hand thread and the other one is right-hand thread. That's why I got to print two. And after that, if you see at the tip here, at the very tip of my finger, if that is the input shaft for the power in, I am going to be putting a gear up close there, and I'm going to be gluing it in with crazy glue. Now if it was let's say the real deal with a pump that can pump, I don't know, maybe 50 gallons per minute or something, or some big pump, it would be keyed with a woodruff key or a woodruff key, or a, I'm not sure what the other term is. It's just a square key which is fitted in the shaft. That would be the coupling between the gear and the shaft, right? And on this side of the gear there would be a thrust bearing that can take a bearing that can take radial and static loads, basically. That's what I'm trying to say. If you look at the thread pattern, there's a right and a left. Now if you put them 180 out of phase and you keep them in constant mesh with gears, where the threads point to, which is in that direction, this is going to be the intake and that's going to be the exhaust. And now I got to build a casing around this. So I'm going to squeeze them together, measure the distance between the shafts, and that's how I'm going to decide where to put the holes on the casing. And I'm going to split the casing in two pieces, and I'm going to try to figure out a way to snap them together. And then I got to make two of the same gears to mesh together. Well, the two gears are done, but here's a learning curve. It doesn't matter which way I flip these, they will always be meshed 15 degrees opposite each other. So one has to be flipped. Like if I made my 15 degrees to the right on this one, I gotta make my 15 degrees to the left. You know what I'm saying? 15 degrees that way. Doesn't matter which way you flip the gear. End for end, they will always line up like that. So when they mesh, they are 15 degrees apart. So I gotta make another design of this gear, but instead of going that way with my 15 degrees, I'm gonna have to make it that way. That's the only way they're gonna mesh. Sorry for the background noise. As you can tell, those one pitches to the right, one pitches to the left, and when you actually mesh them together, they end up on the same plane. And that was what I was aiming for. Oh, there's little buddy. Hey buddy. Oh. So that should do the trick. I'm going to check the spacing. So, zero my caliper. And, oh, sorry about that. Sorry once again. That's what happens when you only have two hands. $195.20, and they're perfectly meshed. So I'm going to see if that dimension matches to what I have on my sketch, and they should mesh mesh with these. I'm gonna try them on. I gotta let you down for a minute. I think I've got it right. I couldn't get more spacing, like I'm gonna have to make do with that gap between the Acme treads. Once again, sorry for the background noise. That should permit to bring some fluid through just the same, but if it was a real pump, I'd have to do a little bit better than that. I just want a proof of concept.